Hello and welcome to the MIT SDM Systems Thinking webinar series. My name is Naomi Gutierrez, Communications Administrator for SDM, and I'm today's host. Today's speaker is Stephen D. Eppinger of the MIT Sloan School of Management. Professor Eppinger holds the General Motors Leaders for Global Operations Chair and is a professor of Management Science and Engineering Systems. He is the faculty co-director of the System Design and Management program. He will be speaking on 10 Agile ideas worth sharing. If you have questions for the presenter, please enter them into the chat window at the side of the video. They will be addressed during the Q&A portion of this webinar. The recording of today's presentation will be available online after today's session. A link will be sent to all registrants. Thank you very much for spending your time with us today, Stephen.
Okay, here we are. Hello, everyone, and a special welcome to our SDM alumni. I know we have quite a few of our System Design and Management Program alumni. I also know several of you have invited some of your friends and colleagues at work to join us, and so that's really wonderful. I'm pleased to be here doing the webinar today. Today's webinar relates to my research in engineering management, which, as many of you know, is something I've been doing for a long time. And the most recent research I've been doing has been looking particularly at how software development works. And what we all know is that software is developed these days very different from pretty much everything else. And the key thing that I've been looking at is, well, why is that? And how does that work? And most importantly to me is, how can we take some of the lessons learned, some of the ideas around Agile, the development method that's used for software, and use them in other realms outside of software? So that's what I want to talk about today. And so I've titled this 10 Agile Ideas Worth Sharing. So I want to share with you 10 key elements of not really Agile thinking, but Agile process that work in software. They work to develop modern software systems and programs and tools and so forth. And the key question I want to really get to is, how could this work outside of software? And the answer to that is, well, it can work, but it needs to be adjusted. And some of these ideas or techniques are relatively easy to apply, that is, relatively little adjustment. And some of these techniques, though, need a lot more adjustment or change or maybe twist in terms of the way they can be applied. So what I will do is I'll present these kind of 10 Agile ideas, and I'll try to contrast them with the traditional method of developing systems. And then toward the end, many of you know my research related to design structure matrix, using this particular method to look at how our systems developed. I've actually been applying that technique to looking at complex Agile system development, and I'll show you a little bit about that toward the end. And I'll save some time at the end. I'll really try to save 10-15 minutes for some Q&A toward the end of the hour. Okay, so let's get into it. So 10 Agile ideas worth sharing, and the key idea is, how do we apply these development practices to engineering systems? So here are the 10 ideas that I want to talk about, and I'll do them one at a time, or maybe 2 or 3 at a time in some cases. I'm going to explain the key idea behind each of these practices and show you a little bit about how it's being applied both in software and outside. Okay, so the first key idea is developing in spirals rather than kind of planned stages. So it's less planned and more iterative. So we'll talk about that. That's been probably 30 years in the making, and I think that's starting to have application in many industries today. The second idea is splitting up the development challenge into what we call sprints, which get time boxed. And by time box, I mean a specific period of time. So it's typically a very short period of time, just a few weeks. And in that time, we do an entire spiral cycle of design, build, and test. And we do that over and over again. So you could think of this as a highly sequential set of spiral iterations of design, build, test. The third idea is having small teams that work in a very specific way. That specific way has been called Scrum. It's kind of a team-based, low-level mechanism within Agile by which teams work. And when the teams work, they have a few specific practices they use. One of them is called the daily meeting, a short meeting where people kind of report in and check in, and it keeps people coordinated. I think one of the most interesting things about Agile is the next one, which I call separating what versus how. We separate the challenge of what to do and give that authority to one person called the product owner. And we separate that from how to do it. And we give that authority to the team and a team leader called the Scrum Master, whose job it is to kind of get the work done and to sort of self-organize themselves to figure out how they're going to do it. So I'll explain how those things work together in this kind of low-level team-based Scrum process. The next one is a visual management technique that's somewhat modeled after Kanban, which is the kind of the process flow method that's the Japanese developed decades ago. But the key idea is it's a visual control and display of the kind of work that we're doing, how we're getting it done, and who's doing what, and then what's been done. And I'll show you a number of ways in which Kanban boards and other visual displays have been used. The next key idea is about feature prioritization. Just to realize that not everything's equally important, and someone needs to prioritize that, and that job may fall to the product owner that I mentioned earlier. But the key thing is to have a way to prioritize the work so that we're doing the most important and useful and maybe high value added tasks first. The next one is called DevOps, and the idea is it's kind of like, some of you remember the technique or the terminology called design for manufacturing. It's kind of like we put these two, if you will, sides of the development puzzle together, development and operations. This particularly has been well worked out for cloud-based software, where we're not only developing, but we're also using and running and that same software. The idea is to get dev and ops to work more closely together through integration and testing cycles. The next idea is called branch and merge, which I'll describe. And this has been pretty well developed through a technique and a tool called Git. And the idea is that we can work separately on portions of the system without disturbing the rest of it, and then merge them back in together in a pretty smooth and useful way. And then finally, just the idea of taking these kind of agile spirals and working them within a planned and staged process. There are a number of ways in which we've both scaled Agile to make them work in a more planned way, but also applied it to more planned and stage-controlled processes. And I call these all various hybrids. So these are the 10 ideas. What I'd like to do is take a few minutes to talk about each one so you can see how they work, in some cases, together. And I'll talk toward the end, particularly about scaling. I'll show you how we've looked at that using some of the DSM methods that I have been using. Okay, so let's jump into it. And the way I want to start is just to point out, just this idea of Agile says, and it's been around for now, I think, almost 20 years. I think 2001 is when this sort of manifesto was written, and I'm sure many of you are familiar with this. But the key idea is it's kind of it's a mindset that says, processes and planning and documents and stuff like that's all important, but even more important is how we work together and getting stuff working and collaborating and even being responsive and reactive to changes, even if those changes come from outside or from customers, because that's how we're going to develop value. And the ideas in this sort of Agile way of thinking have been fine-tuned over the years and practiced in, I guess I'd say, a lot of different ways, some of which we're going to talk about right here. Okay. So, to contrast Agile and spirals to a traditional method, I think it's useful just to say what is the traditional, which is sometimes in software called the waterfall or stage gate method of developing things. And I'm sure you're all familiar. In fact, many industries are still using overall staged development processes. They may be called stage gate or phase gate or I've heard dozens of other variants on this. But the idea is that in each stage, we execute a whole phase or a portion of the work and then have a review. And at that gate review, we're deciding, did we get it right and we move on, or did we not? And we move back and iterate. So we iterate, this is key, iterate inside the phases, not across the phases. Cross-phase iterations would say, let's say we're down here in detailed design and we realize that, the system level or the concept design isn't right. We have to move back to those earlier phases, and those are considered mistakes or unplanned and problematic iterations. To contrast this with the spiral model, first, I thought I'd show you maybe one example of that first from a company that I've worked with a little bit. So Tyco, I could have picked any of dozens of examples of companies implemented this pretty well. Here's an example of, in this case, a 9-stage process, where each stage ends with a gate. And they call the gates, at Tyco, they call them rally points. Tyco's making industrial equipment and controls, and they've fine-tuned this process where they've really carefully defined the 9 stages, defined exactly what happens in each one, and what are the expectations at each gate or rally point. Okay, so I'd like to contrast this with what we call a spiral development process, and I found this old image of a spiral in probably the first paper to document what software engineering calls a spiral development method. It was written by Barry Beam at TRW in the late 80s. It basically said, okay, all those things you have to do in those different stages, instead of doing them just once, what if you could do each of them multiple times? And that wouldn't be the failure of effective management. That would be the plan for effective management. So here you see like risk analysis, prototyping, concept, requirements, detailed design, all that happening multiple times. So you see as the spiral loops out from the middle and it goes through each of those regions, that's when you execute those activities. Let me show you a cleaner version of this diagram. And so this is idea number 1, is the spiral development process. And again, as the spiral kind of snakes through each of these regions, that says you're doing planning, say, multiple times. You're doing concept design multiple times. And in each spiral round, you're doing a little bit of each. And what would the subject matter be for that little bit? The idea is you break off just a chunk of it. So instead of planning everything and doing concept for the whole system, you plan just the first chunk of it, and then do the concept development for the first chunk, and then the system level, what are its connections for that chunk, detailed design, integration, test, and so forth. And then in each of the subsequent spirals, you're just planning the next 1 or 2 pieces of it, and then you're just integrating the 1 or 2 pieces at a time. And so this makes the overall development process highly incremental. And a lot of people have a hard, particularly in complex system development experience, you have a hard time getting your head around incrementally developing so much of it. And that is indeed a challenge, but then you realize, well, you don't do everything at once anyway. But admittedly, most complex system can't be developed in a single spiral like this, but there are still ways that we've learned how to scale it. Let me show you an example of a spiral and how it works at Microsoft. And I'll just explain briefly. The idea is they'll do some upfront planning and then 3 spirals, and each spiral leads to a milestone where, let's just say, 1/3, 2/3, and all of the system is now complete. And the idea is in each spiral, we'll implement one set of features. So they split up in the planning phase all the features and functions into 3 bins. The most important features in the first bin, intended to be developed through the first milestone build. The second most important set of features in the second bin, expected to be complete in the second build, and then the remaining features in the third bin. And the idea is that at each of these spirals, they'll do the design, the coding, the integration, testing of all that set of features. When it comes time for each review, let's say it comes time for the first review, which is at a planned fixed point in time, say, well, how many of those features are done? Well, some, but not all of them. But in a soft review, which is what this first two reviews are, they'll just say, that's okay, you can still move on to the next. We don't stop and move back. But in the second round, you're going to have to finish up those features. And then in the second round, they implement as many as they can. They get to the second review, not quite finished with everything, put the remaining things into the third bin. And then the third round of the spiral, they'll finish as many as they possibly can. It comes to that third, which is a hard review, and anything that's not complete won't be in the product. We'll leave it out, and they enter what they call a stabilization phase, where they're fixing bugs but writing no new code. And then they have eventually it's stable enough for a beta release, and then they learn more bugs and they fix more bugs, and then finally a product release. The point is that they've incrementally built over, in this case, 3 spirals. And this spiral development process has been around for long enough that it's then kind of engendered the next generation of this, which is the more kind of fully agile process. Without maybe having just 3 iterations, we can have many, many more of them. So we'll take a look at how that's being implemented. Okay, so the next 4 ideas kind of go together because the kind of low-level agile that works at the team level, which is largely called Scrum these days, encompasses all 4 of them. Okay, so here's what they are. The time box sprint, the idea that we'll have a plan, a planned sprint cycle, which might be 2 weeks, which is pretty common. Might be 1 week. Many software teams, I've never seen others than software teams use 1 week sprints, or maybe even 4 weeks. But the idea is that sprint cycle, that time box sprint, is always that same period. Let's say 2 weeks. Within the team involves a Scrum Master, a product owner, and the project team, and that's all called now the Scrum team. Each of those has a different role. The team meets together every day, so the daily meeting involves typically a 15-minute morning meeting in which everyone checks in, and the team members would say, what did I get done yesterday? What am I going to work on today? And what problems or impediments do I see getting in my way? And a quick check-in around the room, everybody saying those 3 things, allows everyone to be updated on who's doing what issues, and it's the Scrum Master who runs that meeting who has the job of making the impediments go away. So somebody needs a resource or needs some information or needs to kind of rework something, they help them make that happen. And then the final point about separating what versus how was by having a specific role called the product owner who's in charge of the product requirements, what's a list of all the things we have to do, maintains that list called the product backlog, and prioritizes that list. So the idea is that in this Scrum process, which I'll now describe, in every sprint, that is every, let's say, 2-week cycle, the product backlog has been laid out and prioritized by the product owner. These are the tasks or features or functions or whatever the way that backlog is written out. The team looks at it and says, okay, we have 2 weeks. Now let's take the first most important things off that list, but take 2 weeks worth of work. So the team figures out, what's its pace or velocity or capacity for a 2-week sprint. They take that much work off the backlog, and that now becomes the backlog for the sprint, or the plan for the sprint, which is now then called the sprint backlog. And then through that 2-week process, through the daily meetings and taking things off the sprint backlog, and you could see it on this Kanban board that I'll show you, the team works through as many as they can of that sprint backlog. If they get it right, they'll complete all the work that they thought they could do in that 2-week sprint in that one cycle. At the end of the sprint, we have a sprint review, which involves testing, ideally with stakeholders or customers, whatever the appropriate tests might be. And I guess in pure Scrum and Agile, in principle, we could deliver at the end of every sprint to our customers some kind of working version of the product. Now in software, that's more frequently done. In hardware, it's very rarely done. that at the end of every sprint, we have a deliverable, usable piece of work. So these pieces go together, and it's together in some called the Scrum development process. And the way I think of it is this is kind of the team-based, low-level kind of process that takes place, and that's common across all Agile implementations that I've seen. I'd like to take a couple minutes to say, how could you adapt or kind of use these techniques of Scrum in your own context? So I think I've described everything that's on this diagram, and then maybe one at a time, how would you implement that? Okay, so the first one is you have product managers, and what is the product manager currently responsible? Essentially for success of the product. If that person could act as what we call the product owner, then they say, okay, if I'm responsible for its success, what is it going to take? Well, it's going to take these features or functions or capabilities or whatever those jobs are going to be developed. And so would be responsible for deciding what the team needs to get done and prioritizing that. That list of deliverables has to be prioritized because we want the team to spend its time on creating the most potential value. Now the project leader could be a different role, and the project leader, and we have project managers all the time, but the idea is this is maybe less of a project management role and more of a project leadership role because it's enabling the team to get their work done. Running the daily meeting, running interference and fixing the impediments and so forth. That's really a critical job that we name now the Scrum Master. In each sprint cycle, we select a subset to execute, so that's the task list. One of the hardest things to get over is that we're going to develop the product in this incremental fashion, so that even though we're taking a bunch of things off the product that backlog for this sprint, what's going to create some value, and that's why the product owner's prioritization is so critical. And finally, the team, in principle, is a full-time team, although I've certainly seen this work where people are not full-time members of project teams. But in principle, a full-time team that is, when we say self-organizing, the key thing about it is the product owner and the Scrum Master are not assigning who does what in the team. People are looking at the sprint backlog and saying, okay, I've finished that task, what can I do next? What do I have the skill and the capability to do that's on the list? And if the most useful way for me to use my time is to help someone else get something else done instead of taking the next thing off the backlog, then they could swarm and focus on that. And the idea is we're going to get as much work on the backlog done as possible in that period of the sprint. The daily check-in is a super useful technique. In fact, I don't think I've ever found a team that couldn't implement the daily meeting. I mean, I've certainly found teams that don't do it, but I think of all the methods here that we're talking about within Agile, that's, in my opinion, the easiest one to implement. It's a regular daily meeting check-in, and that coordinates and informs, and probably most importantly, it brings up problems to be solved. And then finally, at the end of each sprint, we have this list of deliverables that we've done. So we've achieved this task. We've completed this element of the sprint and so forth. And those are intended to be evaluated. So while in pure Scrum or Agile we say we could deliver something that's in principle usable by our customers at the end of each sprint, I'd prefer to think of it more broadly as we have a result that's reviewable, that can be evaluated. And so maybe the stakeholders, and it might be the product owner and maybe some representatives from other technical functions, whatever, might evaluate and say, yes, that little piece, that looks like it's going to work. I've tested that and it looks right. Sometimes, particularly user-facing functions could be evaluated by users or customer panels or other kinds of testing in that appropriate way. Okay, so these are the, four of the elements that come together in Agile at the team level called Scrum. Now, it's pretty clear that that was describing one team. Now, what if you had, a product that's large enough that you can't possibly do it in one team of, 6 to 9 people? So typically, large systems, as everyone knows, are decomposed into smaller chunks, or subsystems, or subassemblies, or components. And one way that Scrum can be implemented in larger projects is we kind of maybe do the upfront portion of the development in somewhat the traditional fashion. We develop a concept. We do some useful system architecting, decompose into subsystems, and then have a Scrum team on each subsystem. The integration test phase, by the way, could also be done in those same spirals. So at the end of each sprint, the components could be integrated with the developing system. So even the integrate and test could be part of subsystem development, or maybe the integration test follows a multiple sprint cycle as well, possibly by a smaller set of teams. So there are ways to implement Scrum even in larger projects. There are certainly ways to implement much larger projects in a more full Agile implementation that I'll talk about in a little bit as well. The next two ideas kind of relate to what we just talked about in Scrum. So that product backlog is a list, and that list could be made very clear and visible by using some kind of a board. And I'll show you a few of these boards in a moment. The board could list the backlog, and then anything we're going to do in this sprint could go on our sprint to-do list, which is maybe would be named the sprint backlog. And then as we take things off the to-do list and start working on them, we put them in the next column. Those are things that are in process. And then as they're testing and done. So this is one kind of version of what's sometimes called a Kanban board. I think the most importantly is it's a program board, and it lays out what are we doing in our kind of development program. While I'm on this, I'm going to just emphasize the prioritization. The only things that really should be taken from backlog to the to-do column are the most important items. So we could have a whole bunch of things on the backlog list, but we talked about the product manager being responsible for sequencing or prioritizing that list so that the elements we take to do that we can fit in the next sprint are the most important and useful ones. Let me show you a couple of examples of implementing this. Here's an example from Broad Institute, just right around the corner from us here at MIT, where this is laid out for 3 months, or three months. So this is for a quarter. So the January, February, March. So this is just from earlier this year. I took this picture. And the idea is that each of the different rows is a different team and what they're working on for the different sort of aspects of the work. And when the work gets done, they cross them off with a diagonal line. When the work is tested, they cross it off with another diagonal line, and then they move on to the other thing. So this is just one example of laying out a visual control of work. These teams are not, this group is not implementing all of Agile, but they are implementing this particular aspect of it. Here's another example of a program board from laying out 4 sprints over about 10 teams. You can probably not read at the top, but it says sprint 1, 2, 3, and 4. So 4 sprints. And what are we going to do over 4 sprints in each of these, I don't know, roughly 10 teams? One of the things that fascinates me, and this will be familiar to many of you who know my research in this area, is all those red strings, little yarns between them. Those are interfaces or interactions or dependencies between the tasks of one team in sprint to the task of another team in sprint. Of course, when I look at that, it's pretty obvious. Well, gee, I should lay that out in one of these matrices that I use, and some of that's coming up soon. Okay, so we've seen visual control done a lot in that way with kind of cards, but there are many systems, Trello, Jira, and a whole bunch of others that have been laid out to put this up onto a cloud-based system that everybody can see and use. So here's just one that shows a product backlog. Here's what we're going to do in the January and the next one, the next sprints, the next 3 sprints, perhaps. So this is one of many examples I've seen of using Trello and Jira to implement the visual control. Having said that, I actually really like having the cards on a wall, on a board that people can meet at in their daily meetings, or at least in their sprint planning meetings every 2 weeks, whenever the sprint starts. Okay, so we're up to idea number 8, which is called DevOps. And as I mentioned in the intro, the key idea is to connect development with operations. But what are we connecting them with? So, well, normally you can think of development would kind of throw over the wall to operations. These are things we've developed. Now you kind of test and scale and get ready for release and then operate them. In cloud-based software, which is where DevOps has been working pretty well, although I should say that's largely the only place I've seen it working well, which is kind of interesting. In cloud-based software, we operate the software that we develop. So testing it could start out on dev hardware, and then in the collaboration with operations, it can be then tested on operations hardware. It could then be released to customers to use on operating hardware and so forth. And so having the dev folks working with ops allows any issues that come up through that testing and through the release and even through the ongoing operations to be pretty readily handed off back to the dev team. It can get on their backlog to work on if it's important, critical, a hot fix right now, interrupt the sprint, add it to the backlog. Or it can go on to the very next sprint, which, in principle is just 2 weeks away. So any issues can get fixed pretty quickly, particularly if they're critical. The other thing that this allows, it facilitates, is what we call continuous integration. And so we're not only integrating it into the working system version that's on dev hardware, but we can even continuously integrate it into the operating hardware because the ops team is on the same sprints with the dev teams. I find this interesting to kind of see how it works in cloud-based software, and what I'm wondering is, so what would this mean for other kinds of systems? So in particular for systems that, for businesses that develop operating systems they run that's not just purely software. This could be manufacturing systems, it could be service delivery systems, and the idea is that the teams doing the dev or engineering and the teams doing the operations of those could be working much more closely together. And honestly, I don't see any reason why many kinds of, particularly service-based businesses and manufacturing-based businesses, couldn't be doing exactly this. Although I've never yet seen one doing it. I think that's because most industries outside of cloud-based software have never even heard of DevOps yet. Next idea is called branch and merge. And in software, over the last 20 years, a system called Git has been made, starting with Unix, but really just for anyone now, to take a copy of the working system, branch off a development version, work on a feature or function, and here's the magical part, and then merge it back in. Even though, maybe one team or one person has been working on one feature on one copy and another team has been working on another feature, and of course, when we merge them together, there's a chance that they'll work together and there's a chance that they'll conflict with each other. And the special thing is, obviously the trick isn't in the branching or the tracking, even though it does that well. The trick is in the merging. And how is it that we can merge and then test and assure that these changes are compatible with each other? And when you think about it, well, first of all, the more automated testing we create, and in software, not all software is done this way, but a very common practice in software is for anyone who, as we develop any little bit or feature or function in the software, we also develop a test for it. And the purpose of that is to not only make sure that it works now, but to make sure that in the future, when any other change is made in this portion or any other portion, can be then tested and assured that it works. And so one of the secrets of the merge is when we put it together, we run out all those regression tests to make sure that everything still works. What I find really fascinating about this is, even though it's pretty clear and it's been working pretty well in software for a while, there are some that are trying to figure out how to make this to work in hardware. So for example, in 3D CAD software, in cloud-based 3D CAD software such as Onshape, they've been working on how exactly do we take features that some engineers are working on with features that others are working on and merge them back in together. So they've implemented a Git-based system for cloud-based 3D CAD software models to be not only branched, but importantly merged together. And it finds the errors and incompatibilities, flags them, we can fix them, and then off we go to a working version. Now, finally, and this may interest many of you who currently work in, let's just say, largely planned staged processes. Agile has been combined with stage gate and more planned processes in a number of different ways. So this is one of them. This particular diagram comes from Robert Cooper, a paper by Cooper and Summer, called Agile Stage Gate, and that name Cooper may sound familiar to you if you're familiar with Stage Gate registered trademark to Robert Cooper. So he's the Stage Gate guy. He said, within each stage, there's no reason you couldn't have Agile teams doing sprints every week or 2 weeks or whatever that sprint cycle might be. So that's a pretty easy idea. It says, well, within each stage, split the work up into what am I going to do this 2-week sprint, and this 2-week sprint, and this 2-week sprint. Even if within each stage you split the work up into multiple parallel teams, why couldn't they incrementally plan their work and through within the stages? Okay, so that idea is pretty straightforward, and it's called Agile Stage Gate. It retains the kind of planning and control elements of the gates, of the gating of the process, which involves testing and review and control, along with agile execution at the team level. Another way that this has been combined, I'd say, is by scaling Agile in terms of layering on planning. And this is one of the frameworks for that. It's called SAFe, which stands for Scaled Agile Framework, with a little e after it. And SAFe, there's a whole set of kind of training and procedures around SAFe. But basically what it does, it says we could operate Agile at the team level, which is, let me say, the lowest kind of portion of this diagram, the team level. We could have, in principle, many teams, so we scale it to multiple teams. And then we deal with two key elements. One is scaled planning, and the other is scaled coordination. I'll take coordination first. Coordination means across the teams, people need kind of interfaces from each other. So one team has an interface or dependency on another team. How do we figure that out? And they address it in a couple of ways. One of them is says, well, some of the dependencies emerge. So during this sprint, one team realizes they need something from another team. How do they get it? Well, if it's not already available, if it's available, they just ask the team for it, of course. And who would do that? Well, the Scrum Master would be told, look, I have this impediment, I need this. The Scrum Master meets with the other Scrum Masters in a daily or weekly Scrum of Scrums, a little coordination across them. They get that information. If it's not available, that is, the team hasn't yet done it, then it goes onto that other team's product backlog, which means that the product owners have to coordinate, say, hey, I need this, so, because it's holding me up, you got to create that, and the product owner has to prioritize getting it done. The second way that that's done is instead of just planning one sprint at a time, they plan 4 or 5 sprints at a time in what's called a program increment. And the idea there is the program increment could actually involve, in order to get this done in sprint 3, because we're planning 5 sprints at a time, in order to get this done in sprint 3, I need this to be done in sprint 2 by some other team. That's the element, and I showed you that big sort of program map with the red strings and everything. That's the element that, in my opinion, is not yet worked out really well and needs a bit of improvement. And we're going to try to apply DSM, the method some of you know, for that specific purpose. The next thing about large-scale Agile is planning this at a kind of a longer-term program and portfolio level. And those layers have also been added on to the team-based Agile as part of SAFe. I've been looking at how that works in a couple of interesting circumstances. Right now, I mean, these are just a few of the companies that I've been interacting with over the past, I guess, 12 months or so. One of the interesting things I've noticed is almost every company I work with today says, well, we're doing Agile, or we're trying to do Agile, or we're trying to be more Agile, or we're implementing this form of Agile. It's become part of the kind of regular engineering management lexicon, and I find that to be just a little shocking how quickly that's been adopted so much lately outside of software. So just to pick a few things outside of software that I've been working on lately, it was a fascinating project. It's just wrapping up now. It's the development of a new snack food, and they actually did it in a series of 3 sprints. So one sprint is about recipes and flavors, and next sprint is about manufacturing and pilot, and next sprint's about packaging and taste, and if it were 2 months from now, I could show you exactly what that product is because it's just about to be launched. But it was, and one of the interesting things they developed using part-time teams. That is, essentially each sprint was 1 week a month. So the teams had all kinds of other things to do because they got many other products they're working on. And 1 week a month, they all got together and did those sprints. And in a series of 3 sprints, they got this done remarkably fast. Second company I'm working with, and I'll name this because I'm going to show you this in a DSM in a moment. This is Swisscom, a big telecom company in Europe, developing a whole bunch of hardware and cloud-based connected and online services. And this is one I've been studying about exactly how do they implement SAFe and DevOps. I'll show you a bit about that in one slide. Pharmaceutical industry is trying to figure out, well, how can we do, all the, whatever it is, 2-3 years of work we do in a series of 2-week sprints. And so I've been working with a pharma company on that right now. I'm working with an electrical company that does electronics systems. There's a lot of software in it too, but it's an interesting platform for controls. And so they're doing just tons and tons of electrical and mechanical hardware at the same time as software in a whole bunch of parallel teams. So that's kind of, for me, one of the most interesting implementations of SAFe that I've seen. Aerospace, particularly on the services side of the aerospace business, one of the companies I'm working with is indeed implementing SAFe in that realm as well. Okay, I know we have just a few minutes left before I promise to get to Q&A, so let me just show you one last thing. I say this for the end because I know not everyone in today's online webinar audience is familiar with design structure matrix modeling that I've been doing here at MIT and many others have been doing for years. But for those SDM alumni, here's the cherry on top. So this comes from some work that is currently being sponsored by Swisscom, so telecom systems in Europe. And I've been looking at how do they do, and they have a whole bunch of teams doing Agile in this kind of implementation of large Agile called SAFe. And I just wanted to use this diagram to illustrate a couple of things. First of all, when you layer the planning, so at the kind of quarterly and sort of long-term planning level, they're always thinking about, what do we do in this quarter, next quarter, what should be in the next program increment, which is a series of 5 sprints. So they have this planning cycle, and then within each program increment, they have a cycle that happens about every 10 to 12 weeks of planning for what are we going to do over 5 sprints. And then within each sprint, they do planning. At the beginning of every 2-week sprint, there's a planning process and cycle. So they're layering planning. And then the iterations are happening also at those same 3 paces. So when I say paces, I mean kind of ongoing planning, quarterly planning at the PI level, the program increment level, and then weekly planning at the sprint level. So iterations are happening at those three levels. Planning is happening at those three levels, and it's kind of interesting to see how not just kind of the work is being done in this kind of iterative process, but even the planning is being done in an iterative process, largely at the same kind of set of different periods or paces. Okay, so I've shown you what I've been studying over the last couple of years on how Agile is being implemented. I'm going to skip the second Swisscom example, and I think I want to wrap it up and get to Q&A. So I think we have 10 or 15 minutes for Q&A, which is our goal at the end of the webinar. And so let me just ask Naomi, do we have a bunch of questions that have come in, or any comments, or should I just talk for 15 more minutes?
First of all, thank you so much for delivering this lecture. I thought it was really interesting. I think we're going to wait for a few more questions to come in. Once again, there is a chat window at the side of the YouTube video where you can enter any questions or comments you have. One thing I was actually wondering about is you mentioned DevOps connecting development and operations together as part of this process hasn't really been used outside of cloud-based systems. And you gave a couple of examples of where you thought it could be used, like manufacturing or system delivery processes. Could you talk a little more about what you would envision that looking like in those other fields?
Yeah, so I mean, here at MIT, we have those of us who develop things and those of us who deliver things, and in some cases they're separate groups and teams, and you can imagine, we can deliver it better if we can work more closely together. One of the places I've seen this really start to think about doing it involves service operations within. Well, the one I was working with last week is within kind of large IT systems, and so on the service side, they got all kinds of clients who are asking for stuff every day, and then many of those requests have to be kind of passed on to engineering. Some of those requests service can handle, their operations can handle directly, and so they can work more closely together by implementing a DevOps process. That particular group is not yet implementing a DevOps process, but we were talking about exactly how could that work, and they found some interesting ways to kind of take the lessons learned from the DevOps implementation that I showed them about, one at Swisscom actually, and they said, wow, we changed some of the names, and we really could be doing some of that. Any other questions come along?
Yeah, we're starting to see a few more come in. There's actually one comment from Michael Wallen that I found interesting, pushing back on one of your early examples. He says that the Microsoft example is neither Scrum nor Agile. Stabilization sprints, parentheses, iterations, are considered an anti-pattern. And I'm curious if you have any thoughts on that.
Yeah, so that was, I think you're right, that's not Scrum. It was to illustrate a spiral process, which is, one of the elements of it. But I would say that spiral is only one part of Agile. Sure, that wasn't fully Agile. And to your point about the stabilization sprints being an anti-pattern, sure. I mean, the idea, at least in the kind of full and modern implementation of Agile, in principle, everything we develop, we integrate, and everything we integrate has to be tested, and it's not done until it's stable, that is, it's working. And so that's, I would agree with you that that's not the full modern Agile. That was to illustrate what does just a basic spiral process look like.
Sure. There's a comment, or a question rather, from Curran, who would like to hear more about processes and systems used successfully for regression testing in embedded software, especially after the first integration cycle, which I think you just touched on a little bit, but perhaps could explain a little more.
Yeah, so that's something I have not studied in any depth, so I don't think I can help you a whole lot there. But the key idea is that and we've done this pretty well in most kinds of software systems, if part of the sort of task, what we call the story in software, so part of the job is not only to kind of write that code and implement that feature, but also to test that feature and also to write code that can be later automatically used to test that feature over and over and over again when other people develop, and integrate portions of the code into what you've got. And so the regression testing is this whole set of, sets of code that others have been, that everyone's been writing, so that every time we implement anything, we can assure that the system is still kind of working fully or not. And it can generate, errors that we can identify where we have things to fix.
Very interesting. We have a question from a recent alum, Fred Khalil, asking about whether we're seeing organizational changes in order to implement Agile, which
Yeah.
I was also wondering about.
Yeah, for sure. And I'd say that's true both of kind of small scale and large scale Agile. So, smaller companies and smaller development teams can implement Agile by making these kind of process changes. And the organizational changes are largely the roles that change. Product owner is, maybe a new term or role, but, you probably already had a product manager and you could kind of rework that role into product owner. You probably had a project manager and you could rework that into Scrum Master. So sure, the roles have to change. However, when we scale this, the larger Agile, those functions of what and how and coordinating teams and doing the planning have to happen at every layer. And so that's kind of changing the roles throughout the entire, at least the entire development and operations organization. I think people like to think of Agile as it's also going to be a flatter organization. And well, I don't know, flat is a difficult thing to measure. It's still got a lot of management. It still has a lot of coordination. It still has a lot of roles, that are not just directly developing. So I don't think of it as a smaller organization. It might actually be flatter in terms of, the number of layers and reporting structures, because it fans out quite a lot. So one organization I'm working with has 40 teams organized into 6 groups, which they call release trains. It's a large group, but it's a pretty small number of layers. So it's possible it's flatter, but more importantly, it definitely involves changing a whole lot of the roles.
Interesting. So there's one question here that I think is probably too deep to get fully into, but they asked basically where you would recommend they start to learn more about this topic, if there are books or studies you would recommend. I don't know if you have 1 or 2 off the top of your head, and then if you have a more complete bibliography, I think we could easily send that out to our registrants.
Yeah, well, there's been thousands and thousands of stuff written on Agile. I mean, we could post it. So to learn the kind of team-based Agile about how Scrum works, there are a couple of pretty good books. Trying to remember the name of something like Better Products in Half the Time or something like that is a pretty good book on Scrum. And there's been a whole bunch written on Scrum. Most of that stuff's pretty good. On SAFE, most of the stuff is online as opposed to actual books. Most stuff is online on SAFE. So look up Scaled Agile Framework, and they've got a whole bunch of resources that define everything. There is my favorite book on all of Agile, including Scrum-based, team-based, and Scaled Agile, is a book. It has an acronym. It's called SAGE, S-A-G-E, and it's something like Scaled Enterprise Governance, something or other. I'm sorry, I don't remember exactly what the SAGE stands for, but that's the title of the book, and it's actually very, very good. And we could post the links.
Great, we can
If
get
I had
that
thought
up.
of that, I could just have put it on a slide, but I didn't actually think of doing that for today.
No worries.
What else?
One interesting question from Chris Garcia. Could you elaborate on the similarities and differences between the Agile approach you described and the Lean Startup method, which has also been applied lately to large-scale corporate projects?
Yeah. So Lean Startup applies the kind of Agile thinking to the process of starting up a new enterprise. The key elements of Agile thinking it applies is says, well, rather than kind of having a grand plan and working for whatever, a whole year, toward that one plan, and finding out at the end if that one plan is a good plan or if it needs to be adjusted, can we do this incrementally? That is in spirals. And the key thing is at the end of each kind of development spiral, we ought to have something we can test with customers. And importantly, that test can help us adjust our plan as to where we're going to go next. And then for the next product increment or the next spiral, we could have a different set of features or work to do on the next backlog. And if our test was helpful, it'll actually change what's on the backlog. So we kind of change our plan every sprint. And that's been kind of worked into what's called the lean startup method.
Interesting. It does sound like a lot of these things can interface with each other. It
Yep.
also looks like someone dropped the title you were referring to in the chat. Thank you, Curran. Solutions for Agile Governance in the Enterprise.
Exactly. I think
Sage.
I got 3 of the 4 words right. Agile, governance, and enterprise.
Yeah.
That's right.
Another question from Jason Slybeck. How does Agile work in a situation where there is a high cost of failure on release? For example, imagine a newsworthy release where initial negative press could kill public acceptance of a new idea.
Yeah. So release doesn't have to be all or nothing, all at once. Think about releasing, particularly in a kind of a high-risk situation like that. Think about releasing in a carefully controlled and staged way. So, for example, one company I'm working with, they do it in 4 stages. So the first stage is what they call super-friendly testers. So this is totally internal. So these are people who work inside the company, but are not on the development team and not on the ops team and not on the launch team, but they're people who are, kind of like just regular users, but they happen to be, part of their job is they test whatever we release. And they test it first. And so you do that in one sprint, so in one 2-week cycle. And then the next 2-week cycle, and maybe that's 10 super friendly testers. And the idea is it's 10 people who are using, a different configuration, a different hardware, a different whatever than whatever you had, necessarily used internally on the team. And then the next one could be what they call friendly tester. And that could be 100 people, in this particular implementation, 100 people, real customers outside the company who maybe are paid or they get free products, something like that, to do testing on whatever versions we offer next. And they're expected to put up with some bugs or find some bugs and find some problems. So now you've tested it on 100, essentially outside people, real customers, and we get it working on all their kind of variant of situations of, hardware and firmware and software and configurations and all that. And then the third stage could be a portion of our full user base, 5% or 10%. And then the fourth and full release could be everybody. And that could be done over a period of 4 sprints.
All right, I think we have time for one more question.
One last question.
This one is from Nick Ning,
Okay,
who's
Nick.
asking how to scale up Agile processes across teams by different time zones within a subsystem. So if you have any thoughts on continuous development leveraging different geographical locations.
Yeah. Well, there's no doubt that a lot of organizations have distributed teams. But there's also no doubt that that doesn't make it easy. So just because it's possible to distribute work to different people in different parts of the world, it's not a better or easier process. So sure, for whatever reason, you've got to do that. So one thing, each Scrum team, each Agile team could involve people at multiple sites, and they can, particularly if you have your backlog or your Kanban board or whatever on Jira, so they can, see the work, they can take things and move it to the next column, they can participate in the daily meetings. Sure, it's not as easy as a co-located team, but it's possible. A little bit smarter thing to do is to split things up so you have different teams in different locations. So each team is co-located, but the different teams could be in the different locations. And now the coordination across teams, which is, less frequent than the coordination within a team, is what has to happen across the different sites. And I would say one next step smarter is to kind of lay out all the work and all the interactions and all the interfaces and use that to decide which teams should do which pieces and which sites they should be at. Admittedly, I've not found an organization that has the flexibility to do it that way, but still it makes a lot of sense to me.
Great. Thank you so much, Steve, for
you're
spending
welcome.
your time with us today. And thank you to all of you who've attended this webinar. Again, the presentation recording will be available online after this session. A link will be sent to everybody who registered, but you can also access this recording at the same link you're at now and from the SDM website, sdm.mit.edu. The MIT SDM Systems Thinking webinar series will return in the fall. We'll be sending out information soon about how to submit to present a future webinar. On behalf of the System Design and Management program at MIT, thank you for joining us.
Thank you.